In this video, we're going to take a look at binomial expansion. I'm going to do it using the Pascal's triangle, and I'm going to do it using the binomial theorem as well. So binomial expansion is used when we want to multiply out, say, x plus y cubed. So what you could do is you could say that it is x plus y by itself 3 times, and you could then try to multiply it out. Now, it's not too complicated to do it for cubed, but what if that was to the power of 7, 8, 15, 20? Then what would we do? So binomial expansion is a nice trick that we have that allows us to do it quite quickly. So first I'm going to introduce Pascal's triangle. So I've got, at the top of the triangle, we have the number 1. Then I have 1, 1. Then I have 1, 2, 1. Then I have 1, 3, 3, 1. And you might notice a pattern. What's happening here is there's actually an invisible 1 on the or an invisible 0 on the outskirts here. If I fill them in, it'll make a little bit more sense as to what's going on. And what I'm doing is I am adding these two numbers and I'm putting the result here. Then I do it again. I'm adding these two numbers and I'm putting the result here. And I keep doing that right the way down through our triangle. I add those two numbers and I put the result here. And then I add these two numbers and I put the result here. And so on and so forth. So that's Pascal's triangle. It's a little quick hack as to how we get some of the numbers out when we do a binomial expansion. And what have these numbers got to do with this then? If I was to multiply that out, I would get 1 by x cubed plus 3x squared y to the 1, don't have to write it, plus 3 x y squared plus 1y cubed. Now, how did I do that so quickly? First thing I used was Pascal's triangle to get all of these numbers. 1, 3, 3, 1, because while this triangle has a really nice pattern to it and it's really easy to calculate, it's also really, really useful. If I have to the power of 3, these are going to be the coefficients, so long as these are x and y and not 2x and 2y, we'll talk about that in a minute. As long as those are x and y, those are our coefficients. And Pascal's triangle keeps going and you can keep expanding it down, and then if you have to the power of 7, you can use the seventh row of our Pascal's triangle. So those where those numbers come from. The next thing you need to look at is the powers. So the first thing is the x gets all of the powers. It's all to the power of 3, which matches our power that the bracket's been raised to. The next one then was x squared. It went down 1 while the y went up 1. Because that's actually y to the power of 1. What you'll also notice is that these both add up to 3. If I look at the next one, x went down 1 again. It went from 2 down to 1. And the y went up 1. And then again, the x went down 1 again. It went to x to the power of 0, which any number to the power of 0 is 1. Keep that in mind. Any number to the power of 0 is 1. So we're just left with y cubed. And it's a pattern. Like all things in maths, there's a pattern behind it, and if there is, then we can start to come up with rules for it. And that's the rule using Pascal's triangle. We can describe the rule using mathematical notation now. If I have x plus y to the power of n, it's going to be the sum of, right, so I'm adding them up, that's what I'm doing each time, starting at r is equal to 0, going all the way up to n, of n choose r, okay, n choose r, x to the n minus r, x to the n minus r, y to the n. Now that seems really, really complicated to look at, but it's actually so simple. And it's actually describing that pattern that you're looking at here. So the first thing I'm going to address is this symbol. So sigma, we're going to see it a lot throughout the maths course. It means the sum of, so you're going to add them all up. That's this part of the formula here. So I added them up. this N choose R, that's actually a button in your calculator you can use. It's the choose button. And if you have N and you choose the R, it'll give you actually the numbers from Pascal's triangle. So if I did, for example, N is 3. If I do 3, choose, and I'm starting at the very beginning, and if you look, it tells us where to start. R starts at 0. And if you put into your calculator 3 choose 0, 3 choose 0 on your calculator will give you 1. The next one that I do, that would be 3 choose 1, because I keep going from 0. I go to the next one, which is 1, all the way up to N. So I keep going. There's the first one, 1. The next one would be 3 choose 1 then. That would give me 3. If you do that in your calculator, you get 3. The next one then, this guy, 3 choose 2. If you do that in your calculator, you get 3. And then the last one, because it says start at 0, go to N, the last one's going to be 3 choose 3. And if you do that in your calculator, you'll get 1. And if you look at each of those numbers, 1, 3, 3, and 1. Those are the numbers in Pascal's triangle. So in an exam, they're not always so nice to give us to the power of 3. They might give us to the power of 20, to the power of 15. So that's where I would have a preference for using the choose formula rather than using Pascal's triangle. So let's go back. That's the choose explained. That's what the N and R mean. So I've explained what that is, and that's effectively Pascal's triangle. So I'm going to put that in blue. That's where those numbers are coming from. Then it says raise your x to the power of N minus R. Now, I made a little mistake here. Let me correct it. Raise your x to the N minus R. That's going to start at R3, in this case, take away 0. So 3 take away 0 is 3. So that's why it's x cubed. Then the y is to the power of R, which in that case is 0. But y to the 0 is going to be 1. So this formula, in the log tables, it describes exactly what you need to do to get this out. And it was only through hundreds of years of mathematicians performing this expansion by hand and figuring it out using Pascal's triangle that we actually were able to condense it into mathematical notation and explain it in maths terms, and we've it in this nice neat packet now, and it's just about being able to read it. So it starts with the x getting all of the power because R is going to be 0, and then you're going to pass 1 off each time to your y. So let me just do an example of that with a plus b to the power of 4. So how I'm going to do that then is using this formula. The sum of just means add, so I can leave it blank for a second. I'm going to have 4 choose 0, because I start with the R as 0. My n is the 4, whatever I'm raising it to the power of. So 4 choose 0, x to the power of n minus r. So in this case, our x is actually a. So if I identify, like what do I have in common between the two formula, that's my x. So I'm going to have a to the power of 4 minus 0, b to the power of 0. And I can leave it like that. I can tidy it on the next line. Then I'm going to have plus, and then it's going to be 4 choose 1, because I'm going to keep going. Why have I said plus here? I've said plus here because it's saying the sum of in the formula after I do this. So I have to have all of those things written down first. They are all multiplied, by the way. There's no symbol in between saying add, divide, subtract. There's nothing. If they're brackets side by side, back to back, it's multiply. So all of these are multiplied. That's multiplied plus, and then we start the pattern again. 4 choose 1, a to the 4 minus 1, b to the 1, plus 4 choose 2, a to the 4 minus 2, b to the 2, plus 4 choose 3, a to the 4 minus 3, b to the 3. And I'm going to have to move this over now to fit the last one in. But this was all created using the formula up there, being able to understand that notation. And then it's going to be plus 4 choose 4, a to the 4 minus 4, b to the 4. And then it's a little bit of calculator work. So this I can do in my calculator. 4 choose 0 is 1. A to the 4 minus 0 is a to the 4. B to the power of 0, any number to the power of 0 is 1. So I can just say multiply by 1. It just leaves it as that. Plus 4 choose 1 is 4. Then I'm going to have a cubed and then b to the 1. I can leave it as b. I can put it to the 1 if I want. 4 choose 2. So 4 choose 2 in our calculators is 6. So I'm going to have a to the 4 minus 2, which is a squared, b squared, plus 4 choose 3. That's going to be 4. A to the 4 minus 3, which is 1, b cubed, plus 4 choose 4 in my calculator is 1. A to the 0, anything to the power of 0 is 1, so 1 by 1 is 1, and then multiply by b to the 4. And you can check that you've got it right. If you look at all the powers, when you add up all the powers, they should always total to 4. So I definitely know I've got the powers right. And then for the coefficients, you can go back and check them. Or if you look at the next line of Pascal's triangle, add 3 and 1, 4, add 3 and 3, 6, 3 and 1, 4, and then our 1 on the outside. So that's an example of a nice straightforward expansion with binomial theorem. It does get more complicated. An example of when it gets more complicated is if I have a minus b to the power of 4. So have a think before I go through it. Maybe hit pause. Have a think, how is it different to the one I did before? So the minus is the big difference between what I have now and what I've had before. So what I'm going to do this time, I'm effectively doing the exact same calculation, but anytime I deal with that b, I need to make myself aware that it's a minus b. So I'm going to put that b in brackets when I put it in. So I'm going to have minus b to the power of 0. Then I'm going to have by minus b to the 1 by minus b squared by minus b cubed, and then minus b to the 4. And then it's the same process. You're going to do the same thing. 4 choose 1 is 4 choose 0 is 1. 0 to the a to the 4 minus 0 is going to be a to the 4 minus b to the power of 0. That is still just 1. It's still just 1. So I'm going to have minus b to the 1 is just 1. I can put in multiply by 1, but hopefully you know that multiplying by 1 is just the number itself. So I can leave it as such. The next one then, 4 choose 1 is 4. A to the 4 minus 1 is a cubed. And then minus b by to the power of 1 multiplied by this. If I multiply by minus, that's what I'm going to have. Minus 4a cubed b, because minus b to the power of 1 is minus b, and then it's multiplied by all of this. A minus by a plus is a minus. Then I'm going to have plus 4 choose 2. 4 choose 2 is 6. A squared minus b to the power of 2. Here's a quick trick for you guys. If that's even, this always works out to be positive. So if that's even, this is positive. So I'm going to have plus, multiplied by, b squared. So it's a positive b squared multiplied by that. So I don't put the plus in because that would mean something different. I want it to mean multiply, so no symbol in between. Plus then, we're on to the next one. 4 choose 3. And then it's going to be a to the 4 minus 3, which is 1. Now, minus b cubed. If it's to the power of an even number, it's plus. If it's to the power of an odd number, it's minus. So this actually needs to go to minus. And I forgot here 4 choose 3, which is 4. So a to the 1, and it's b cubed. So that minus came from here, and then 4 choose 4, which is 1. A to the 4 minus 4 is a to the 0. Any number to the power of 0 is 1 minus b to the 4. If this is even, that is positive, so b to the 4. So that's another step up. The next video we're going to go through an example where we have a coefficient in front of the a and the b, and then we raise it to the power of something.